of Palmax. Okay. Now, for this case, you have to be what? Really, really cautious. Why? Palmax is not necessary. I'm not saying it's not. It's not necessary to be at the way at the centroid. Now, let me ask you some questions. What happens at the centroid? Let me give you a hint. I want you to focus on the ratio Q over T. Let's focus on Q. At the centroid, what happened to Q? It's the maximum. Right? Q is at its what? Maximum. Agree? Now, can you see where the thinner section is? Yes or no? The thinner section is where? You have thin section here and here. Right? Let me ask you, in the thinner section, is it point A or point B will have the largest Q? D. Yes or no? Because the analysis starts from what? Y max. Be clear? The analysis starts from Y max. B will have the what? Larger first moment of area. Is it larger than the centroid? But remember, the shear stress is dependent on what? The Q over what? P ratio. Now, at the centroid, can someone tell me how much is P? How many? At the centroid, 40, 50, right? How about at the wet section, at point B? What is the thickness? 1. So we don't know, right? We don't know until we calculate what is which one has the bigger ratio. Is it at the cross section or is it at point where? Point B. Are we clear? That is the problem with this talk. What did we just do for the past 5 minutes when I was guided? What were we doing? Yes, it is well done. It is what we call what? Analysis of what? Fundamental.
Answer clearly.
Are we clear? This is important. The difference between you now and you before is your mindset of what? Analysis. That's the problem with this course. It's not just like formula, dumb. No! You pick the wrong point. You know, it's about who? There you go. Are we clear? Okay, so just the trick about this is you have to really do a lot of what? Practice. Are we clear? Or not? We are done. Right. So let's do the calculation then. So we are going to do the Q calculation again. Are we clear? Okay. So we're going to select. Okay. So we know now we are still going to do the Vy over Izz. Okay. We are still going to do this. Okay. Don't worry. But now I want to focus on the what? We're going to focus on the QZ over T ratio. Are we clear? Okay. So now we are going to determine the QZ at point B, where the thickness is equal to what? Is equal to twice 0.01. Why twice? Because when you design your shear flow, what will happen? It will go what? Left and what? Right. Are we clear? Okay. So I'm going to call this our top flange. Then this is our web. And then this region is our lower flange. Okay. Now, we know by visually, this is our centroid, yes or no? Over here, this is our centroid, okay? So we are going to calculate our QZ for the top flange. And I always adopt this, the width, depth, Y bar. And we know that this is our width. And over here, this is our what? Our depth. So from here, our width is what? 50. Our depth is what? 10. Our Y bar is what? 20, 20, 20, 30, 60. 20 plus 30, 50, 60 minus by 10 divided by 2. So from here, we get, oh, sorry, I'm going to, wait. I'm going to convert all to meters, okay? It's best to do all this in meters. I mean, you can convert later, but I don't want to confuse you with the converting. So this is equal to 0.06 minus by 0.01 divided by 2. Turn on your calculator first. 0.06 minus 0.01 divided by 2 times by 0.01 times by 0.05 is equal to 27.5 times 10 to the power minus 6 meter cube. Let me do it again, okay? So the depth is 20, 50, 60, 0.06 minus 0.01 divided by 2 times by 0.01 times by 0.05. Okay. Then we are going to calculate the Q at the web, or the Q at point B. Okay, I'm going to call it our Q at point where? At point B. So this is equal to 27.5 times 10 to the power minus 6 plus by the width, which is equal to twice, because we have left and right, twice 0.0 what? Twice 0.01. That's our width. Our depth now is equal to what? Our depth now is 0.03. Our Y bar now, we have to be careful, is 0.02 plus by 0.03 divided by 2. Can you all visualize this? So we are taking this distance now. Okay, we are taking this distance now. Okay. So from here, you have 27.5 times 10 to the power minus 6 plus 0.02 plus by 0.03 divided by 2 times by 0.03 times by 0.01 times 2 is equal to 21 times 10 to the power minus 6. Let me do it again, okay? So twice 0.01 times by 0.03 times by 0.02 plus by 0.015. Okay. It's 21 times 10 to the minus 6. So this will be equal to 27.5 power minus 6 plus by 21 plus by power minus 6 is 48.5 times 10 to the power minus 6 meter cube. Then we're going to find the Q at the centroid. Yes, sir. Because 0.02 is the distance from here to here. 0.03 divided by 2 is the distance from here to here. Okay. So 27.5 power minus 6 plus by 21 power minus 6 is equal to 48. So the Q centroid now is equal to 48.5 times 10 to the power minus 6 plus the width is equal to what? The width is going to be equal to 50. The depth is going to be 20. Come on, Eugene, in meters, in meters. The width is 0.05. The depth is equal to 0.02 multiplied by the Y bar 0.02 divided by what? Divided by 2. So this will be equal to 48.5 times 10 to the power minus 6 plus 0.02 times by 0.02 divided by 2 times by 0.05 is equal to 10 times 10 to the power minus 6. Okay, so I will do again 0.02 divided by 2 times by 0.02 times by 0.05. Okay, so over here you have 48.5 power of minus 6 plus by 10 power of minus 6 is equal to 58.5 times 10 to the power minus 6 meter cube. Okay, so now from here, then we can locate. Okay, we can locate the position of max. Okay, so at position number B, at B, the shear stress at point B is equal to what? Vy over Izz. These are constant. Now your Q is equal to what? 48.5 times 10 to the power minus 6. The thickness is twice of what? 10 millimeters. Okay, twice of 10 millimeters. So this is equal to 48.5 divided by 2 divided by 10 power minus 3 is equal to 2.425 times 10 to the power minus 3 Vy over what? Izz. Let me do it again. So 48.5 power minus 6 divided by 2 power. 48.5 power minus 6 divided by 2 divided by 10 power minus 3 is equal to 24.25 times 10. So now, if we calculate at the centroid, so this is equal to Vy over Izz. Now you have what? Can you see the first moment of area is the what? Is the biggest. Yes or no? Now, however, what happened to the thickness? The thickness is also the what? The biggest. Okay, so now this is equal to 0.05. So from here, 58.5 power minus 6 divided by 0.05 is equal to 1.17 times 10 to the power minus 3 Vy over what? Where is the position of the largest shear stress? B. Are we clear? Okay, so now over here, tau max will occur at point where? Point B. So this balancing act of Q over T is the balancing act, yes or no? They're fighting against what? One another. Right? It's not easy to get the largest first moment of area when you have a very thin what? Thickness. Are we clear? Then I'm going to challenge you now. Okay, I'm going to throw more monkey wrench into your question. So now we have a structure looking like this. Did something happen? Now I want you all to stay with me, okay? Don't die yet. Stay with me. Okay. So now what I want you to do is, how does the shear stress distribution look like? Yes or no? So you have to visualize. So remember what I told you guys at the terminal, what happened? So these are the terminals. All right, these are the terminals. Over here is a terminal. Over here are the terminals. So we know at the terminus is equal to what? 0. Right? Then it is going to increase. Second order polynomial equation is a curve. Then after that, it's going to do what? It's going to go up. Why did it go up at this location? The thickness reduced, right? Then it's going to do this, right? And then after that, it is going to come down. And then it's going to do this. Okay, by the way, I'm not drawing a rabbit, okay, but it happened to look like this. Batman. No, Batman. Yes or no? Right? So mathematically, there you go. Okay, you have to what? Visually understand how the distribution look like as a mechanical engineer. Are we clear? Okay. Now, within 2 hours, what I've taught you, you can do all the questions in assignment 1. Assignment 4. Are we clear? For the next 2 hours, after today, I will handle the most difficult questions on the assignment, on the homework. Are we clear? Okay. Now, you have to what? Apply the rules and what? Practice. Are we clear? The video is there. Keep on watching it. Okay. I'll see you guys on tomorrow.